Alright everyone, welcome to database class. So today we are going to discuss a model called entity relational model. So in this class we are going to cover four main parts. The first one is how to use the entity relationship modeling in database design, and then the second one is the basic concept associated with the ER model, including entities, relationships, and attributes, and a diagrammatic technique for displaying an ER model using the unified modeling language, one of the modeling language I think you guys already familiar with. And the last one is how to identify and resolve the problems with the ER. In previous weeks, you guys already learned some of the techniques for gathering and capturing information about what the user require of database system, usually using some questionnaire or simply ask about what they are needing in the database system. And then once the requirements collection and analysis stage of the database development lifecycle is complete and we have documented all of the requirements, now we are ready to start the database design stage. One of the most difficult aspects of database design is there's a fact that designers, programmers, and end users tend to view data in different ways. So, for example, in ITS itself, if you open your myITS and then me as a lecturer open myITS, we will see different data because you cannot access some part of lecturer can access. So because user has a different ways, unless we all gain a common understanding that show how the company operates or how some organization operates, the design we produce will fail to meet the user requirement. So to ensure that we get a accurate understanding of the nature of the data and how it is used by the organization, we need a model that can be used for communication that is non-technical and free ambiguities. So this ER model is used to clearly understand the data and how a business use it, and then it have to be easy to understand by all of the user and without any more confusion. So it's free from ambiguities. And then ER modeling is a top-down approach to database design. So it begins by identifying the important data called entities and relationship between the data that must be represented in the model. And then after you identify all of those entities and relationship, then you can add more details such as like information we want to hold about the entities and the relationship we call attributes, and any constraints on the entities, relationship, and also the attributes. So ER modeling is a conceptual design techniques used to visually represent the structure of database. Like in the picture on the right side, you can see one of the example of ER diagram for the example that we are going to discuss throughout this class today. And ER modeling helps you answer the question of what data should be stored in the database and how are they related. So basically, this ER modeling will help you answer this question. And a little bit history. So it's proposed by Peter Chen in 1976 as a way to structure data before implementing it in a relational database, and it's object-oriented. For example, if you use modeling language UML, it will look like on the right diagrams. But of course, you can use other modeling language, but it should be clear and free from ambiguities. So the objective of entity relationship model is to create a high-level blueprint of a database that shows entities, attribute, and relationship. I think you already knows about entities. So entities basically is the thing we want to store data about, and an attribute is the properties of those things, and relationship is how things are connected to each other. So ER modeling is an important technique for any database designer to master and form the basis of the methodology. Right, so the basic concept of ER model is the entity type, which represent a group of objects in the real world with the same properties. An entity type has independent existence and can be object with a physical existence like stuff, property, customer, etc. that you can see physically their existence, and they can also be object with a conceptual existence like viewing, inspection, and etc. There's also term what is called entity occurrence. So entity occurrence is each uniquely identifiable object of entity type. So we identify each entity type by a name and a list of properties. So a database normally contains many different entity types. For example, in the pictures on the right, there is some entity types called staff, branch, property for rent, private owner. So each entity type is shown as rectangle, and they will label by the name. So staff, branch, properties for rent, private owner is called the name of the entity. And usually we use a singular noun to name the entity. And the entity, usually in UML, the first letter of each word in entity name is uppercase. So you can see here staff, the S is uppercase, branch, or for example, if contains more than one word, for example, property for rents, and each of the words will start with uppercase letter. Another basic concept of ER modeling is relationship type. Relationship type is a set of association between one or more participating entity type, and its relationship type is given a name that describes its function. And there's also a relationship occurrence, the particular entity occurrence that are related. So for example, in the example in the right figure, you can, let's say, we consider two entities, branch and staff, and then they have a relationship type called has, which represent an association between branch and staff entity. So in other words, we can say that branch has staff. And in semantic net example, usually we use this circle with rectangle outside to represent a relationship, and then circle represent the entities here. So in this figure, we can see the example of relationship. Call it R1, R2, and R3. So we have three relationships here. And then each relationship describes an association of a single branch entity occurrence with a single staff entity occurrence. For example, relationship R1 represents the association between branch entity B003 and staff entity SG37, and so on. And usually we represent each staff and branch entity occurrence using value for the primary key attribute. For example, in the branch, the primary key is branch number, and for staff entity, the primary key is staff number. So I think you still remember what is primary key attribute. So the uniquely identifiable each entity occurrence. If we represent the relationship using semantic nets or semantic network, it can be hard to understand because they show too much detail. And the ER model is easier for showing the relationship here because it uses a higher level abstraction, making it simple to read, especially for a lot of users. So ER model is done by grouping similar objects into entity types and grouping similar connection into relationship types. For example, from the semantic net example in the picture above, we can convert it to the ER model in the picture below. So we have staff and branch, and in the relationship here is has, and then you can see the arrow of the relationship, and we will talk about the arrow a bit later. And this relationship, we can interpret it as branch has staff. We will discuss in detail about how to build a relationship later. For diagrammatic representation of relationship types, usually each relationship type is shown as a line connecting related entity types. So we have line here, and the line is labeled with the name of the relationship. Usually the name should contain a verb like supervise, has, manage, or maybe short phrase with a verb like list by. And each word in the relationship name starts with a capital letter, and the relationship name should be unique in the ER model. So there should not be more than two relationship type that has the same name, and it can make it difficult. And the name is written in one direction only, meaning that it should make logical sense in that direction. For example, brand has staff, so that's the direction of this relationship, not the other way. So entities involved in a particular relationship types are referred to participants in that relationship, and we have degree of relationship type, which means that the number of participating entity type in a relationship. So for example, in the left picture, it is an example of binary relationship called P owns. So the private owners owned the property for rents. And then there's also another example. If you have more than one relationship, for example, it's called ternary relationship. There is register here. This is a complex example of relationship. So register, there are three participating entity types, which are staff, branch, and client. And this relationship represents the registration of a client by a member of staff at a branch. So here we have the complex relationship. Usually we use complex relationship terms to describe the relationship that has degrees more than 2. So if you have 2 degree in the relationship, it's called binary. And then more than 2, we will call it a complex relationship. It's either 3 or more, it's a complex relationship. So usually if you have degrees higher than binary, we use the diamond to represent those complex relationships. For example, here, if you have 4 participating entities, buyer, solicitor, bid, and financial institutions, we not we denote the relationship type as a diamond here. So a range here is a relationship types that have four participating entity in this relationship. So in this case, we can say that a solicitor arrange a bid on behalf of a buyer supported by a financial institution. So this is an example of what is called quaternary relationship. The next terms I want to introduce to you guys, it's called recursive relationship. So this is a relationship type in which the same entity type participates more than once in different roles. So here we have some role names. Role names show the function or purpose of each entity in relationship. And then here role names will help clarify which entity plays which part. And they are also helpful when two entities are connected by more than one relationship. For example, here staff and branch, they have more than one relationship. But sometimes role names are not needed if it's already clear what each entity does in the relationship. So for example, here we have manager manage branch office, and branch office has a member of staff. So there's role name here, manager, above the staff to clarify the role names, and then branch is called branch office. That's the role name of the branch. So to clarify the manage relationship, we add role names here. So manager, manage, branch office. And then for the has relationship type, we have another role name for the staff entities. It's member of staff. So we have branch office has member of staff. So it's not manager anymore. So it's how to clarify which entities place in the staff part. Another basic concept of ER modeling is called attribute. So I think you're already familiar with this term. So attribute is property of entity or a relationship type. So usually attribute stores the detail or information about each entity. And I think this is also, you already learned about this. There's also attribute domain, so a set of allowable value for one or more attributes. So for example, if we have for student entity, and then in student entity we have attributes called grades. And then the attribute domain for this attribute called grade is maybe between 0 to 100. So attribute is set of allowable value for one or more attributes. So let's say we have 3 attributes in the entity. They may share a same domain, but also domains can also be composed of domain. So I will explain about it later. And then attribute can be classified as being a simple or composite, single value or multi-value, or derived. So the first grouping is simple and composite attributes. So simple attribute is mainly an attribute composed of a single component with an independent existence. For example, in student entity we have ID, student number. It is an example of simple attribute, or maybe name, but name could be composite attribute. So composite attribute is an attribute composed of multiple components, each with an independent existence. For example, in the student's entity, we have attribute called address. So address could be um, composed of multiple components, for example, house number, street, or even pin. Pin here is maybe the postcode, or maybe name could be also a composite attribute. Maybe it consists of first name and last name. So that's when the attribute can be break down into different multiple components, it will call a composite attribute. And then another group is single value and multi-valued attribute. So we can define the attribute based on this value. For single value attribute is an attribute that holds a single value for each occurrence of entity type. And multi-value attribute is an attribute that holds multiple value for each occurrence of entity type. And one of the example of multi-value attribute here is maybe phone number. If you see, some system will allow you to input more than one phone number. So that's what it's called multi-value attribute. So it allows you to have more than one value for each attribute, for one attribute, sorry. And then the last one is derived attributes. So derived attributes are not stored directly. They are usually calculated from related attribute or maybe related set of attributes, not necessarily in the same entity type. So let's say age in the students, maybe we can get the age attribute for student entity from the calculation of this year minus the year of they were born, something like that.